If you remember before Christmas we had and or statement, and we had the graph on a number line. Remember doing that?
Yeah.
Well, if we have the absolute value of x, for instance, and this is section 6 point, I believe it's 6.6. Okay. And we're going to cover part of it today, and I'll cover the other part on Monday. But if we have the absolute value of a number equaling, let's say 4, and we know in case 1, x could equal 4, and in case 2, x could equal -4. Right?
Yep.
Okay. If we had, and the work is the same, this is not a lot different except for one little thing here. If we have the absolute value of x is less than or equal to 4, here's the way we're going to solve that. We go case 1 and case 2, just like we did the others. In case 1, x is less than or equal to 4. And here's the part that's different for case 2. In case 2, whatever's inside is greater than or equal to the -4. So we have to change that sign for inequalities, and that's the only thing that's going to be different for us. And then they're going to ask you to graph it on a number line. So let's see what kind of a graph this looks like. We have our 0 here. Over on this side is your -4. Over on this side is your +4. Do we have open circles or do we have closed circles? Closed. This first problem here says x is less than 4, but the other one says x is greater than -4. No arrows. And so we have this and statement. Remember, if it's between two numbers, it's an and statement. And I can write an and statement this way. -4 less than or equal to x less than or equal to 4. And if you look at your drawing, isn't x right between -4 and 4? And that's what this says. Okay. Let me give you another example. I'm just going to give you a few problems to work on for today, but let's say the absolute value of x plus 2 is greater than, let's say greater than 8. Okay? Case 1, what's inside is greater than 8. In case 2, what's inside is less than -8, correct. Okay, so it's not really a lot different, is it? And then we solve these two equations, but let's see what kind of a graph we get here. We're going to subtract 2 from each side. In the first equation, case 1 says x is greater than 6. We're going to have a number line here, and I want you to tell me if it's an and statement like the one before it, or possibly, what's the other one? An or statement. So we'll subtract 2 from here, and x is less than -10. So let's put our two values here. We always want to put where 0 is. And over on the right of 0, we have 6. Over to the left of 0, we have -10. Do I have closed circles or open circles? Open. And let's do with a 6 first. X greater than 6. That goes to the right, doesn't it? Over here, x is less than -10. It is an or statement, right? So x is greater than 6, and we read out the word, or x is less than negative 10. Bless you. Mhm. Okay, all set with that? All right, let's take a problem like this then. 2, absolute value of 2x plus 3. Oh, let's go minus 4 is less than or equal to, maybe 10. Okay, so let's do a problem like that. Nick, what do we do first? Add 4, that's correct. We can't go to case 1 and case 2 yet, so we're going to add 4 to both sides first. The result is going to be 2 times 2x plus 3, absolute value, is less than or equal to 14. And now what do we do, Nick? Divided by 2 is correct. So these 2's will cancel. I didn't divide by a negative, so I don't have to flip the sign. Right, Zach? So I have the absolute value of 2x plus 3 is less than or equal to 7. Now I can go to case 1 and case 2. Case 1, what's inside is less than or equal to 7. In case 2, what's inside is greater than or equal to negative 7. And we'll see if this is a conjunction or a disjunction. We'll see if it's an and statement or an or statement. So I'm going to subtract 3 from each side in case 1. I'm left with 2x is less than or equal to 4, and I divide by 2. X is less than or equal to 2. Okay? Here's 0. Here's 2. Less than or equal to. So we have a closed circle. For the other side, in case 2, I'm going to do the same thing. Subtract 3 from each side. 2x is greater than or equal to negative 10. And divide by 2. X is greater than or equal to negative 5. I didn't divide by a negative, Austin, so I don't have to flip that sign, right? Because I divided by a positive 2. Well, here's 2. Over this side is negative 5. Also a closed circle. And if you look at that, Sid, the first one says I want x is less than 2. And the other one says greater than negative 5. So greater than negative 5, but it's less than 2. So that's an and statement. And we write it this way. Negative 5 less than or equal to x less than or equal to 2. And this is an and statement. Okay, is that clear? You guys were so attentive today. I'm just going to give you a few problems to do. We'll cover part 2. There's some more stuff here, but we'll cover those on Monday. But I'd like you to do on page 401. And let's do problems 3 through 16. So that'll give you 13 problems to work on in the last few minutes of class. Okay?